Hi, I am Chappell Rebigsol. I try to present the topic that the universe is infinite, is ironclad. And indeed, a lot of argument from the other side holding the view that the universe is limited. Those arguments actually become, a lot of times, becomes supportive to the idea that the universe is infinite. In history, the main argument against an infinite universe is the Olber's paradox. The Olber's paradox holds that if in the infinite sky we have infinite stars, it will give infinite brightness in the sky. But we don't see an infinite brightness in the sky, so the sky cannot be infinite. But when this paradox is written, some, due to history reason, some fact we don't learn by the time yet. And the fact is that all stars has limited time span. And all stars has different birthday. In other words, all stars that we know come together, they can only take turn to shine on the sky. They cannot have infinite number of stars to shine on the sky. And so when we have dark sky, we can only say that because different group of stars taking turn to shine in the infinite sky, that's why we have a dark sky. So the Olber's paradox cannot be there against our idea that the universe is infinite. Okay. If the sky is limited, we have to come to one concept, edge. If there's no edge, there's no limit. Very common sense. But the edge, there are two concepts of edge. One is geometrical only. Another concept is an edge with physical material. If the edge is only limited to geometrical sense, it means that this edge has space on both sides. On one side, that's where the universe is. On the other side, the universe is not there. At least the universe we know of is not there. In other words, the space on the other side that has no universe is infinite, unless we can prove there is a limit on the other side, but we cannot. Right now, so far, we have only one edge separating the universe that we know and the other part. In other words, the universe we know of is owned by two parts of space. One part is on the side that we think the universe is. The other side is not where the universe is. But since this space, the two space is a continuous one, it means that the actual universe is in the infinite space, only a parcel of it is occupied by the so-called universe that we know of. The other concept calling that you are limited the universe is by the evidence of cosmic cosmic microwave background. And the problem is, according to the Big Bang, the cosmic microwave background is the remnant of microwaves from the time the Big Bang exploded. This has been 13.5 billion years, according to them. The problem is, nowadays, we found evidence saying that the universe that we know of is expanding with acceleration. In that case, the microwave can only travel at constant speed. So there must be some day that microwave cannot catch the edge anymore, and then leave some big space between the edge and this microwave, so-called remnant. And if this microwave cannot catch this edge, how can the remnant come back for our detection? So-called remnant is like the sound echo. Once we stop talking, the echo cannot come back anymore. The sound cannot come back anymore. What we hear is an echo. We call that the remnant. But if the microwave cannot catch the edge, they cannot come back for our detection. So they cannot come back as remnant. As a matter of fact, to this observer over here, every star is a source of microwave source, radiation source. And that source can radiate the microwave toward us, or each of them can do this. That's actually what we have been detecting, but misunderstood it as remnant. They are not remnant. They are firstborn microwave. The problem is, surrounding us, surrounding the observer, we are having the same kind of microwave coming and embracing us. So in every direction we observe, we can receive that kind of microwave. However, because some reason we mentioned later, we will see that almost the same radio wave intensity in every direction. But whatever we detect, it is the firstborn radio wave, it's not remnant. Otherwise, we have to explain those firstborn microwave, where do they go away if we don't pick them up with our observation instrument? So I believe this microwave come together, the first-hand microwave come together is what we call as the cosmic microwave. That's the true cosmic microwave. It is not the remnant. Now we have observations supporting that the universe is expanding with acceleration. Continuous acceleration means continuous force. If that force continues to exist, no explosion has complete. Once the explosion is complete, we don't have continuous force anymore. Whatever the moving is only consuming the momentum it has carried, it has been endowed with, but no more dual momentum invest in that moving object. And eventually, that moving object must slow down instead of expanding with acceleration. To Big Bang theory, I believe accelerated expansion is a impassable stone wall to Big Bang. But on the other hand, the fact of accelerated expansion, it can serve as a pillar to support an infinite universe. If the universe is infinite, and we can have high possibility that high internal energy material that's laid in front of those whatever the objects moving. But the moving object, number one, they are hot stuff by themselves. Number two, they have a high mechanical momentum. If they happen to land on a big cloud of high internal energy material, the consequence is obvious. Can cause explosion. The explosion by itself can send out a lot of stuff out, burning, moving. On the other hand, before this material is landed, those incoming material already have huge mechanical momentum. When it lands on this cloud, the cloud explodes. This cloud, when they move, they also inherit the previous momentum from the incoming part. So the new material moving out would be faster, moving faster than the incoming part. That's how we end up seeing the star moving with acceleration. But actually, the acceleration is not compared with respect to time, but compared with respect to distance. Just like this. This traveling at constant speed. However, it's faster than I can move. Okay? So in between these two groups of objects, it seems this is moving with higher speed or acceleration. But this object actually is moving with constant speed, except that the speed is higher than the speed I carry. And then my speed also higher than the original object that landed on me. So compared to the three groups, we are, each of us, moving faster and faster. Give us the illusion that something is accelerating, but nothing is accelerating. Everybody is traveling in constant speed. But this happens only if we have an infinite universe and with infinite stock of material of high internal energy. If Big Bang theory is true, the universe is born after a completion of certain singularity, explosion. Then a concept of large batch of material must be introduced. With that last batch of material flying away from each other, behind them, there must be a space of absolute emptiness, because the singularity explodes, no more explosion, no more material is created. So this last batch of material, because they fly from each other, they must circle an empty space I call void. With 13.5 billion years of movement of this final batch of material, the void must be gigantic, unimaginably big. But so far, nobody claimed that they can see a big void like this in the sky. So if we cannot find this void, we most likely can reject the idea that singularity ever explode and bring us a universe. Another impassable stone wall to the Big Bang theory is relativity. The main framework for the Big Bang theory is Einstein's relativity, special relativity particularly, and with the special space-time as one single physical unit. And it brings up a lot of fairy tale-like explanation to the evolvement of the universe. Unfortunately, to pick up BBT and Big Bang theory, if it relies on relativity, it has to find that relativity is invalid. These three groups of equations are primitive equations from relativity. But with these three groups of primitive equation set, it must bring to the production of the equation. With this equation, since 1 and this is equal, we must have v equal to 0. In other words, two supposedly systems moving with respect to each other, actually they don't move at all in relativity calculation. With v equal to 0, and we plug in back to the equation set, we must have c equal to 0. Now, relativity has to answer one question. Should the speed of light be 300,000 kilometers per second as it assumes? Or should the speed of light be 0 as it proves? If the special relativity cannot answer the question, and relativity cannot be valid, relying on an invalid framework, Big Bang theory cannot be valid either. If Big Bang theory is true, whatever the mass it can imagine must have an upper limit. As soon as the explosion stops, I don't care whether it stops in 3 seconds after explosion or even 3 years after explosion. As soon as it stops, there exists an upper limit for the entire mass of the universe. And then we must have a concept, center of mass for the entire universe. With the existence of a center of mass, gravitational influence must eventually pull out the entire mass material toward the center. Yeah, also, there may be a possibility that momentum is so huge for all those material, it can forever overcome the initial momentum is so big that it can overcome all the gravitational force coming together. And then we cannot have accelerated, expanded universe, but must have a universe which, if it expanded, it must be decelerated, not accelerated expansion. again now, to overcome the mass center grab. If we have an infinite universe, and then we don't have to worry about the center of mass, because the entire universe cannot have a center of mass to be defined. And if all the material that give us the illusion of expanding, they can fly to unlimitedly. And because behind them, they don't have a gravitational force to pull them back. Everywhere they go, the gravitational force in the large scale is zero to them. Here's another question I would like to ask. How come it's so coincidentally that when we have our observing instrument be very sophisticated, upgraded, and then at the time window, we can see the newborn star from far away. This absolute coincidence out of 13.5 billion years. Suppose those young star, very young star, firstborn star, did not come so quickly. So when we have this good instrument, we don't see this. We can only see this at a closer distance, an older star. If the star, no. If we have been, if the star, that the image come before we invent the instrument, we can only see at the same distance. If we find new star today, we can only see old star because their younger portrait has been passed behind us. We cannot see them. Again, if the universe is limited, we can only see up to this certain distance. Behind that, we see nothing. Nothing is allowed to be seen because the universe is limited. Okay, now here's my my conclusion. The universe is infinite, and no matter how the detectable universe we can see today is only a tiny spot in the entire infinite universe. That infinity is going all the way. Okay? If you expand to this big, but outside there's still infinite, okay? There is no limit. So whatever we see in the universe today is only the detectable portion of the universe. It's not the entire universe. On the other hand, I would like to say this, because the speed accumulation for the outer edge star moving faster and faster, someday we will detect a phenomenon like this. The further away the stars, actually they are stellar collection. The further away they are, the bigger mass gathering they will become. The reason is some star hit me, and then I hit the next one. Besides transfer momentum, we may transfer some mass too. So the future collection of this mass gathering may have a chance to become bigger and bigger statistically, and not absolutely. And still, because this collision, the tiny CM and the big star cloud can coexist in the universe. But no matter how, this universe is infinite. So, thank you.
All right, questions? Okay.
That's all.
A very interesting paper. Thank you.
Thank you very much.
Oh, Mike? Shall I put that on?
Steve?
We got questions.
I don't want the mic, I was gonna give it to him.
Okay.
Oh, okay, no? Okay. All right, no questions then?
Good.
All right, well, thank you so much.
Thank you.
Thank you.
Thank you. All of you present interesting. Thank you.